Okay. So where we left, yes, you told that you were
Actually,
getting.
current would be from.
So what
Sir,
you are
actually, I
missing?
made mistake, sir. Actually, it would be from plus two minus polarity here.
Okay.
Can I draw it here once again, sir?
Yes, yes, you can draw it. Wait. Draw here now.
When we take when we take this way plus minus, then current would be from here to here, sir. GM. Let's say this difference is Vx, sir. Then it would be from GM Vx in this way, sir.
Can you on your camera also, or it is not feasible too? Okay, fine. So you are in the hostel now.
Yes, sir.
Okay, you are in the college now.
Actually, I'm at an internship.
Where?
IT matters.
Okay, IIT Madras. You are in the hostels now in IIT Madras.
Yes, sir.
Okay, fine. Okay. So what was you telling? Tell me.
So current would be GM. If this voltage is Vx, then it would be from negative to positive. This was the GM to Vx.
Okay.
Here, the, it's in this way, no, sir. The current would be flowing towards this node, sir.
Hmm.
And this the current due to this one, it would be flowing away from the node. So the current approaching that node equals to leaving the node, sir. Then it would be fine, sir. Vx into SCC equals to
So
GM
here
2
also you
times
are
Vx.
getting right side zero. What is the problem with right side zero?
It adds phase, sir. Pole adds minus 45 degree, but decay, no, sir.
Hmm.
Same with same with right side zero, sir. Right side zero will add a phase down, negative phase, sir.
Okay. So what you did to overcome this problem in your
We can
design?
add a RZ.
Okay. So what it will do?
Uh, we'll choose RZ value such that 1 by GM of that P equals to, so that zero the effect of zero won't be there, sir.
Why are you not using RG greater than 1 upon GMP so that this zero can be shifted to left
Yes,
also?
sir. It would, we can use that also.
You can use that also. Or RG less than 1 upon GMP or RG greater than 1 upon GMP? What will you choose?
1 by GM minus RC greater than.
Greater than. Okay. So what is the exact transfer function you got after introducing this RG also? What is the transfer function for you?
Function A into 1 plus S by omega Z by omega P1 plus S by omega P2
What is the
where
omega G
omega
here?
would be 1 by CC into 1 by GM minus RZ, sir.
If RZ is
Or,
greater than 1 upon GM, then what?
sir, RZ minus 1 by GM.
Okay. Now it's correct. So you cannot take RG lesser than 1 upon GM2, otherwise,
It would be in positive sign.
yes, yes.
RSPG.
So this is the case. So what is the Bode plot now?
What a plot. Actually, it would be having some games. GM1, GM2, RO2 parallel, RO4, R1, R2, maybe that
Hmm.
one.
Okay, anyway.
And when we'll encounter the first pole omega P1,
No, don't write complete thing. Yeah, direct write FPF, whatever like omega P1. So here you can write the DC gain only. Need not to write everything. DC gain and DB. Okay, fine.
then it keep on decreasing with 20 dB per decade, sir. Then
Okay.
afterwards, we'll design in such a way that the omega P2 will be after UGB, sir.
So how will you ensure this thing that your omega P2 is coming after UGB? What is the condition
Omega
for that?
P2 is, you see, this one is
Omega
GMP
P2
by
is
CC,
right.
sir. This
What you are writing
omega
omega
P2.
P?
Yes, sir. GMP by CL.
CL, okay.
Whereas UGB is GM1 by
Human Y?
GM GM1. One second. Can I calculate some?
What is you are writing omega P? That GM1Y, what you are writing?
UGB, sir.
UGB, okay.
I think it's GM1 by CC, sir. So it
Okay.
should be greater than this.
Okay.
From that,
So,
we'll do, sir.
okay, GM2 of second stage divided by cap will be okay. So, is this body plot correct according to whatever model we have taken initially? Like I told you that R1 and R2 are very large, infinite. What was your dominant pole?
So then it will be S equals to 0, sir. Then it will be this way, sir. From starting only, it will be having minus 30 dB per decade.
Okay. What about the zero?
Now afterwards, 0, as it will be GM by CC. Only without RZ, sir.
Whatever. First without RZ and after that RZ. First without RZ, what will be the location?
Without RZ,
Yes.
GMP by CC, sir.
So where would you like to locate it?
Omega P2 is GMP by CL, sir. CL will be larger and CC will be smaller, sir. So omega Z will be greater than omega P2, sir.
No, no. I mean to say with respect to UGB, where would you like it? So is it important to see the
It would
location of
be
this zero with respect to omega pole 2 also? Or it is only response like important to see its location with respect to UGB only?
with UGB, sir, mainly.
With UGB is the only interesting thing we are interested in.
While
So
calibrating
why?
phase,
So what is the condition for that then?
it should be far away from UGB, sir.
Why far away? Why not two time, three time, four time?
That means the phase, while calculating phase, it will be will do minus tan inverse of
Okay.
omega
So
Z
for
by
so fine. So you want to keep it far away from the UGB. So what the condition for that?
condition means.
How will you design it
Sorry,
to keep this pole the zero away from the UGB?
actually, we'll take omega Z generally 10 times UGB in that way, sir. Generally,
Okay,
the
that
format
so
is
what
like that.
so what is the condition for that GM condition? I want to ask now. That is fine, but what with the GM modification?
Sorry, sir, I can't get it.
I mean to say, you are saying that this is the condition. Okay, fine, I got the condition. But what are the parameters which will be affected by this condition? So I want exactly the
We'll
scaling and
get
those
a
parameters.
relation between
Which
we'll get
which
a
will
relation between CC and CL from here, sir.
CC and CL with this condition omega g equal to 10 UGB.
By taking omega Z is
So I mean to say by taking omega g equal to 10 times of omega mu, what you are
will
getting
be
condition
GMP by CC equals to 10 times GM1 by CL, sir.
CL.
Uh, GB. Sorry, CC.
So
GMP will be 10 times GM.
so CC cancel now.
Yes, sir.
So anyway, GMP should be whatever you want to
10
say much
times.
greater than of GM1, or if you want to say 10 times. So anyway, if we are keeping GM of second stage higher than the first stage, then we are well stabilized or something we are doing good. Okay. So this is the discussion on this. Fine. Okay. So, so this is good discussion for two-stage AMP. Now I'll give you other question. So I want to see what is the differential gain. One thing, and other thing I want comment on the biasing of transistor. Comment on the biasing of transistors M3 M4. Okay, this is C.
That can during differential can we short that capacitor
What will you short?
capacitor C during finding the gain.
I want to see the effect of cap also. I want a gain with good differential gain means with frequency also. First you calculate DC gain if you want, then you can see the effect of that cap also.
That does it have we must have a lambda output resistance RO.
That you can consider, but very high.
V1 V2 values of this.
Hmm?
V1 and V2 values.
These are the V01, V02 values. What are the differential gain?
Should we take GM1 and GM2 to be equal or separate? Sir?
It should be equal.
minus GM ROP.
GM
Minus GM times ROP.
ROP only. What about the means output impedance of M1 M2? We are not considering that.
Sorry, sir. ROP parallel RON.
Okay. So okay, that I got. Can you quickly consider the effect of this capacitor in the gain?
Can you move page above?
Hmm. Okay.
Think while finding differential gain, it would be shorted, sir.
They will be shorted.
That means
Are
there's
you
a,
sure?
that means finding half circuit while doing half circuit one analysis, sir.
Okay.
Then that C can be splitted to 2C parallel 2C.
Fine. So what will be the half
Then
circuit? Can you draw the half circuit?
this
Complete structures half circuit.
extra this impedance will be added, sir. 1 by 2 SC.
Where is your half circuit?
This one, sir.
What your half circuit is telling? Something like what this effect of C is you are looking for. It is not looking at a load capacitance. I mean to say,
Sir,
if you are drawing a half circuit like this, incrementally it is ground. It is ground. There is a 2C. Here is V in. This is incrementally ground. And here you want to see the V out
R,
one. And we are not seeing that this is something offering me some R load parallel to this 2C. So effectively we can see now, if this is my actual structure that I want to see, V in 1, and I want to compute this 2C as a load, this as a current source, having R naught P as a impedance. Here I want to compute the power. This is the simplest form, no? Simplest form. Now you know everything what to do with this circuit. Simple common source amplifier.
minus GM into
Got it?
this, sir.
So what is the like pole location here? That I wanted the
Okay, sir.
effect of capacitance also, no? In the
Okay.
gain.
Minus 1 by 2C into ROP parallel R1.
Obviously. So this is my pole. This is a dominant pole. So effectively what to be the gain then? That it is a first order system only.
So what's it?
So here only pole is there, no? So that is the first order system. So what is the gain expression? Complete gain expression for the amplifier?
A by 1 plus S by omega P.
Of course, the simple. What the UGB then?
UGB A into omega p, sir.
Yes, so it is the first order system, simple A equal omega G. My target was to look at the circuit and simplify it, and after that, how will you deal with this cap? Sometimes they can give you the cap differentially in between the structure. You have to draw the half circuit if it is possible. Just take cap as a load, and you can proceed to calculate
Sir,
gain with the
actually,
first order.
I also drawn before previously in that same way only, sir. That means 2C ROB
Okay, so
parallel R1.
I could not follow it properly. Okay, it was not looking very
Sir,
clear, so I thought that you did something. Okay, fine then. So you got the concept, no?
yes, sir.
Okay, let reach to the third question. Okay,
So initially at T equals to 0 plus there will be 5 ampere current flowing through it, sir. And cap would be short circuited at T equals 0 plus, sir. So current flows in this way and in this path, sir. So V output at T equals to 0 plus would be 5 R2, sir. Then
so at t equal to 0 positive, you told that your caps are shorted. Okay, so complete current is going this way. Okay, fine. What the output?
5 R2.
Okay, got it.
And then due to due to the current flowing through C1 and C2, there will be voltage developed across it, sir. Let's say some V1 volt R1, C2 and 2. Then what happens is the current through this will decrease, sir. It would be less than 5 ampere. Here the current would be constant 5 ampere only, sir. So due to this 5 ampere constant current, the cap will be get charging, sir. As current is constant, then the voltage will be increasing linearly, sir.
Okay, so what
So
should be the output
then,
expression you want?
then initially it will be 5R2, it would be increasing linearly.
Okay, the 5 output is increasing linearly. Okay, so what kind of expression your V out will get? What kind of plot or expression will it get? First of all, tell me the
Sir,
order of the system. Is it the way
uh,
that we are analyzing it in the first order system or something else?
order of the system, sir.
Hmm.
Actually, it's a second order, sir. Let's take C1. Let's take it has some voltage of current IC1. Uh, s- both these two are independent energy storing elements, sir. They are not
Okay.
related to each other.
Hmm.
So it would be a second order one system. It will also depend on whether where we are taking the output also, sir. For example, here if you are taking the output of current here, that it will be first order, sir.
So as we are pumping the input as a current, then what should be the output expression?
Where here's output voltage.
Hmm. Is it
It as
dependent
an
on the C1 R1 C1 output voltage expression?
no, sir. Oh, no, sir. It would be
This
having
current
a time constant infinity, sir. It
time
won't
constant
settle.
infinity. Yes, because we are getting continuous charge on the C2. The current is fixed.
Yes, sir.
Okay. Anyway, that is fine. I got okay voltage expression. So can you exactly tell me if there is an input instead of current, I am having some input voltage. I am taking voltage at output. So I want
Yes,
to
sir.
see the poles and zero location for this system.
Poles and zero location, sir.
Yeah, just yes. I want to
When we have voltage as input or current as input, sir.
both voltage as input and output both. Like I will redraw it. So this we have R1 C1 and we have R2 C2. What do you want?
Poles and zeros.
Yes.
So for finding poles, we'll find time constant minus 1 by time constant will be poles, sir.
Okay.
And it's a first order system, sir. So we are doing that way. Why? Because when we consider voltage across C1 as some VC1, then sorry, sir, it's not a first order system.
You told no first order system. What?
Actually, I thought R2 CD are in parallel.
So what you
It's
to do
not a first
then?
order. So to find we can find zero, I think, sir.
Okay, zero you can find. So what is the zero?
For zero, this impedance should be infinity, sir. It means
Why?
R1 by 1 plus SC1 R1 should be infinity. That means 1 plus SC1 R1 equals to 0, sir. S equals to minus 1 by C1 R1.
So this is your 1 0.
Yes, sir.
Okay.
And due to
This is
C2, due to C2, this impedance should be 0, sir.
okay.
R2 plus 1 by SC2 should be 0. So SC2 R2 plus 1 equals to 0.
So we are getting two zeros. One is R1 C1, other is R2 C2.
Understood.
What about pole?
Pole, I
How
think we
many
can't find intuitive.
how many
Can't
poles are
find
there?
intuitive. Two poles, sir.
Two poles are there. So can you assume a condition that if let I am giving a condition that two poles are well separated, then can you compute them in this circuit? Let's assume both poles are well separated. They are not interacting much. So can you have some intuition after that? For the hint, one more thing that I can do for it. Let's say my C2 is 10 times C1. Can you have some hint of calculating zeros? Oh, sorry, poles. And on the opposite, R1 is much greater than R2. These are two conditions I mean. Can you see something? Okay, you can think
This
in free time.
impedance, this
It will
impedance
take some
will
time.
be this impedance will be less, sir. Z2 will be less and Z1 will be more.
Anyway, that is fine. But it will take some time. Whether you can do one thing, you can analyze in the free time. But just the condition of pole, you know that apply that condition Z1.
Z1 plus Z2 equals to 0.
Z1 equal to minus of Z2. Yes. So apply this, and after that you will get a quadratic equation in the S. In that equation, you
Then we
assume
can neglect S square terms.
it can be then you get one pole only. So if you are getting some sort of, let's say, s square plus as plus what say I say a square as square plus bs plus c equal to 0. Let's say you are getting some sort of this equation. Then what can be done? You can write it as a by c s square plus b by c s plus 1. So if you consider that both the poles are well separated, then what it can be now? What is the general expression for the pole if they are separated? 1 plus s tau 1, 1 plus s tau 2. If you are opening this equation or completely, then what you will see, tau 1
plus
tau
S
2
square
tau 1 tau 2 s square plus tau 1 plus tau 2 s plus
plus 1.
1 equal to 0. Now you compare both these equation. You will find that one condition you can assume, if you are assuming tau 1 is much greater than tau 2, simply means I am assuming that f p1 or omega p1 is much lesser than omega p2. In this way, I am considering that my both poles are well separated. So with this condition, anyway we can get something. Okay, fine. You can analyze this or you can think more on this. Not a problem. Okay. So I think now 7 minutes are left for the session. So I'll ask one thing on some. Have you done the noise analysis and offset mismatch all?
No, sir. It's not there for
No.
syllabus.
As of now, not for you, huh?
No, sir.
Okay.
In BTech curriculum, it's not there.
Yes, 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 yes. That's why I asked. Okay. So MOSFETs, op amps. Yes, anyway, we can take one question from the op amp. Have you gone through this switch cap circuits?
Yes, sir.
If one is open, let's say mm, 1 volt. Wait. 1 volt. Okay, so can you plot the V out? Let's say gain is very
Sir,
high.
gain is very high, then we can have it. Then op-amp will be working in negative feedback.
That's great. But one thing is there, okay, phi 1 and phi 2 are two non-overlapping clocks that you know, I think.
And
Okay.
we have an plus V, minus V, plus V, sir. Plus V and minus V sets.
That you can consider. That I'm not giving you anyway. That are large values you can consider. What is happening with it?
C1 will be, when 5 is on, C1 will be charged to 1 volt, sir.
Okay.
When it's charged to 1 volt, output would be minus V set. So the
No, C1 is charged to 1 volt. Okay. Then why it is minus, you said?
it's applied at the negative terminal of op-amp, sir.
It is applied on the negative terminal. But when Y1 is on negative terminal, is on zero now.
Sorry, sir, sorry, sir. 0 volts.
So
Output would be 0 volt only, sir. As
Hmm?
capacitor C2 is initially uncharged, output would be 0 volt, sir.
Output will be 0 volt. Hmm. If switch is not there, switch 2.
If switch 2 is not there, sir,
Hmm.
that means it's open circuit. Here, that's open circuit, no, sir.
Then
As the capacitor C is initially uncharged, output would be 0 volt only.
hmm, phi 1 phi 1 is on, we are getting 1 volt across the capacitor. Okay. When phi 2 is off due to virtual short, we are getting 1 volt 0. Here it is 1 volt. So to this node is 0. This is 1 volt. This we want 0 0. So I think something I'm missing in this question. That's why it is not looking very proper. You can do one thing. You can take this 1 volt charge from here. Yes. Instead of here, you'll take phi 1 here. Oh, wait. I think something is missing. Exactly missing something. So we'll see this question. I'll send you. I can take some other question as of now because some means switch position is not properly coming in my mind as of now. That's why the problem is coming. Okay, so time is about to over. I'll send you this question. So what is my feedback as of now? You could answer the questions properly, but keep while you are solving the questions now, you should be confident. The interviewer might try you to confuse. So whatever you have to be very calm while you are solving. And instead of solving the questions in hurry, you have to take the pause and you can ask or you can keep your discussion little interactive. Instead of giving the solution after 10 minutes, better you can talk them. If there is a physical interview, usually TI happen like that. So you can say the interview that I'm approaching this way, you can tell. So at least the final conclusion what you are giving is not coming wrong. So this is and be confident while you're answering. Overall, it is good. Now keep revising because you have only 1 month left now. Yes, keep revising the concepts. Do this more basics, op amps, two-stage op amp, basics of. Usually they will ask the RC only. So it is going to be over now. It is about to close the session. Anything?